Okay, class, yesterday we started chapter 9, and we're working with systems of equations. And just a reminder from yesterday, we found that systems of equations are two or more equations in the same variable, and they form a system. And we saw the solution of those two equations is the ordered pair that satisfies or makes both equations true. And yesterday we looked at the idea of graphing, okay? And today we're going to start the idea of, instead of graphing, how do we solve these systems of equations algebraically? And the first method that we're going to look at today is called the substitution method. All right? Now, again, if you look here, it says there's several algebraic methods for solving systems of equations. Each of these methods involves obtaining a third equation in one variable. So we're going to look at this idea of substitution. All right? Now, if I have everybody look with me really quick, here at problem number 1, if you notice I have a system of equations. I have two equations, but the first one already has y isolated. So what we're going to do to solve this system of equations is we're going to take this y that's isolated and plug it in for the y in the second equation. So it would look something like this. We have 5x y, and when I substitute in the first equation, y equals 2x equals 30. All right, and so now what would be my next move? Well, I would go ahead and combine like terms. 5x minus 2x is 3x. 3x equals 30. And if we divide both sides by 3, we get x equals 10. Now remember, my answer has to be an ordered pair that satisfies both equations. So now that I have x, I need to take that x and plug it in the y equation, because we said y equals 2x, to find our y, to get our ordered pair. So this is going to be 2 times 10 because we found x was 10, and so this is going to equal 30. Now, when you get done, I want my answer to be an ordered pair. Remember, they go in A, B, C order, so my answer, whoops, this should be a 20, sorry gang, okay, would be 10, 20, all right? So, the idea of substitution, most students like it better than graphing. Personally, I would rather graph and be done, but we're going to do a lot of still kind of going around in circles, solving to get both equations. So let's go ahead and look at example number 2. Very nice. Yes, once again, hey, you realize they've already isolated one of my variables. They've already said c equals. So we're going to plug that in for the c in the second equation. So we know that c is 3d minus 4. We just plug that in for c, plus d equals 16. Okay, so now what do we do? Well, we're going to combine like terms. 3d plus d gives me 4d minus 4 equals 16. We're going to get rid of our floater. We're back to those properties of equality from chapter 3. 4d, and when I add over there, we're going to add 4, so we get, what is that, 20. And when I divide both sides by 4, what does d equal? d equals 5. Now, we need to find c. Remember, my answer has to be an ordered pair, so we're going to take the d that we just found and substitute it back into the first or the original equation. c equals 3 times d, which is 5, minus 4. So we've got 15 minus 4, so c equals 11. All right? And so our equation would be 5, 11. Our ordered pair that satisfied both equations is 5, 11. All right, now let's look at our third example here. If you look at our third example, a little bit different. What's different? Yes, I don't have a variable isolated already for me. Now, here's the key to being successful when we're using solving by substitution. We need to solve for the letter that's all by his lonesome. Yes. So when I look up here, I want to get x alone. I don't want one of those with a coefficient in front because I'm going to have to divide and I'm going to have fractions, and I don't want to go there. So what we do when a variable is not isolated for us, we take the variable that's all by his lonesome and get them together. So that means I've got to add 2 to both sides. So we're going to have x equals negative 4y plus 2. Now that we've isolated a variable alone, we're going to plug that in to the original equation. We're going to go ahead and plug him in there. So we've got 3 times x, but x is now negative 4y plus 2 plus 2y equals 11. Everybody see what we did? Okay, what should I do next? Right, distributive property. So we've got negative 12y, and then we've got 3 times 2 is 6, plus 2y equals 11. What do we need to do now? Yeah, combine like terms. What's negative 12y plus 2y? Negative 10y plus 6 equals 11. Yeah, 6 is my floater. We're going to subtract 6 from both sides. So now I have negative 10y equals 5. Everybody see what our answer is? If I divide both sides by negative 10 and I reduce the fraction, we're going to get y equals negative 1/2. Now remember, my answer has to be an ordered pair. And so I found the y, so how do I find the x? We're going to take the y and plug it back into our x equation. So what do we have? Well, x equals negative 4 times negative 1/2, which is y plus 2. So x equals, what's negative 4 times negative 1/2? Yeah, that's positive 2. So we've got 2 plus 2, so x equals 4. And remember, we're going to put them together, and my answer is an ordered pair. Remember, they go in the ordered pair in alphabetical order. So x goes first, which is 4, and y is negative 1/2. So, not very difficult. It's things we've been doing for a long time. But you got to really be careful of the little things as we go through. Well, let's go ahead and look at our next one. Let's look at number 4. Now, when I look at number 4, okay, first of all, I notice that there's no variable alone. Okay? And so that's a problem. And the next thing I realize is I've got a fraction. Well, do we like fractions? We've already decided that we don't like fractions. So the first thing I need to do is elimination. So how am I going to get rid of this fraction? Well, we know we've got to multiply everything by 2. If I do that, we're going to get y minus 2x equals 2. Everybody understand what we did? And now that's pretty easy to get y alone. We've just got to add 2x to the other side. So y equals 2 plus 2x. So once again, if I don't have a variable already isolated for me, I need to do that. Now, we're going to take this y and we're going to substitute it into the other equation. So what does that look like? Well, we've got x plus y. Well, y is 2 plus 2x plus 7 equals 0. Now what should we do? Yeah, let's go ahead and combine like terms. X and 2x gives me 3x, and 2 plus 7 gives me 9 equals 0. Oh yeah, we got to isolate the variable by inverse operations. So let's go ahead and subtract 9 to the other side. And then to get x alone, we got to divide both sides by 3. So x equals negative 3. Are we done? No. We found the x part of our ordered pair. Now we have to find the y part. So we know that y equals 2 plus 2x. And we just found out x is negative 3. So now what do we have? 2 minus 6. And so what's my answer going to be here? Yeah, so what do we get? So we're going to get negative 4. So when I put those together, all right, let me check this out and make sure I didn't make a mistake. Okay, so it's going to be negative 3, negative 4. Remember, your x and y come together to be your ordered pair. Now, let's look a little more in depth at some with way more fractions. Again, as soon as I see fractions, boo hiss, hiss boo, elimination. So let's get rid of them. So if I look at number 5, and I look there where my LCD would have to be 10. So what happens if we multiply everything by 10? Remember, so something's going to cancel. We're going to get 5c minus, what's that going to be, 2d equals negative 40. And now we need to take the second equation. What are we going to have to multiply that by to eliminate all those fractions? Yeah, we're going to have to multiply it by 15 over 1. So that's going to give me 10c minus 9d equals, and 15 times negative 7 is negative 105. Now, kind of nasty, but we need to get somebody alone. Who do you think we should solve for? Well, I'm just going to not be very diplomatic. I'm going to go ahead and take this one. And I think I'm going to solve for C. So if I solve for C, what's going to happen? Well, we got to add 40 to the other side and divide by 5. So here's what's going to happen. We're going to have C equals negative 40 plus 2d divided by 5. And Mrs. Burton's going a long way home. C equals what? I'm going to go ahead and rearrange the furniture there. And I'm going to get negative 8 plus 2/5 d. Now, it looks kind of nasty, but we're pretty good at math. We're 8th graders, so let's see what happens. Now, remember, I'm going to plug that c into the second equation. So we've got 10 times c, which is negative 8 plus 2/5 d minus 9c equals negative 105. Now, some of you said, oh man, Mrs. Burton, nasty fractions, what are we going to do? Well, if you just hold on for a minute, things might work out pretty nicely. Let's see what happens. What's 10 times negative 8? Negative 80. What's 10 times 2/5? Yeah, did you realize we get 4d? So it kind of took care of itself. We got rid of those fractions. Minus 9c equals negative 105. Let's combine like terms. So we've got negative 80. 4d plus negative 9d is what? Negative 5d equals negative 105. We're going to have to add 80 to both sides. So that's going to give me negative 5d equals, is that negative 25? It sure is. Negative 25. So d equals 5. Now remember, we found d, but now we have to find c. My answer has to be an ordered pair. All right? So let's plug our d in. So we've got c equals negative 8 plus 2/5 times d, which is 5 over 1. See, it works out nicely. So we've got negative 8 plus, the 5's cancel, plus 2. So that's going to give me negative 6. So my final answer then, remember C, D, they go in alphabetical order. So it'd be negative 6, negative 5. So a lot of algebra from chapters 2 and 3. A lot of little things to watch out for. Signs, definitely long and drawn out. Now, we are going to have a few problems for homework that have these directions. It says determine whether each of the following systems has no solution or infinitely many. And if there are infinitely many, give 3 of them. All right? So when I look at number 2, again, I need to get a variable alone. And the easiest variable to isolate to get alone for me to solve this is this y. But there is a negative in front of it. So that's okay. We've got negative y equals 1 minus 2x. And I can't have a negative y, so we're going to multiply everything by negative 1. So we're going to get y equals, and I'm going to 2x minus 1. So when we rearrange the furniture, that's what happens. Now, we're going to go ahead and substitute that in for this y. So we've got 3 times y, which we just figured out is 2x minus 1, plus 3 equals 6x. 6x minus 3 plus 3 equals 6x. And you may realize here, oh my goodness, the 3's cancel, so we have 6x equals 6x. What happens when we have the exact same thing equals the exact same thing? Well, this is just like having lines that coincide. Yesterday, we have infinitely many solutions. Okay, so they want 3, so we just need to pick 3. So we can just do an input-output chart. If they want 3 answers, because that's what it said, give 3 of them. So let's pick a 0. That makes life easy. And we get negative 1. Let's pick a 2, and that's going to give me 4 minus 1, which is 3. And let's go ahead and do a negative number. Let's do negative 2. That's going to give me negative 5. So if they wanted 3 answers after I realized that, oh, the exact same thing equals the exact same thing, that's infinitely many, just like yesterday when we had the lines coincide, I can just use this equation, do an input-output chart for 3 different numbers, and there's my 3 answers. I have 0, negative 1, I have 2, 3, and I had negative 2, negative 5. Nicely done. Now, I think that's it. So I'm going to let you go ahead and start your homework, and we'll pick up here tomorrow.